we're going to go over how to transpose a matrix. Say we have matrix A and it equals, I don't know, let's give it a thing. Give it some values: 2, 4, 9, 6, 4, 3, 2, 8. What number haven't we used? And a 1. Now, if we want to transpose this, basically what you do is you turn the columns into rows and the rows into columns, and it basically flips. So if this were a matrix, you would say that this with a T, which this means transpose, would equal, well, the first row would be the first column. So the first row is going to be 2, 4, 9. And the next one's going to be 6, 4, 3. The next one's going to be 2, 8, 1. So there it is, transposed. Now it's notable that if you transpose it yet again, it goes back to what it was before. So you would say that this also equals a transposed, put that in parentheses there, transposed again. So it just transposes right back. Now this is a case with an even-sized matrix. If the matrix is not even-sized, or square rather, because that was a 3 by 3 we looked at. So what if it's not? What if it's, I don't know, let's 2, 7, 9, 6, 8, 0, for example. So that one there being a 3 by 2. Then something a little different happens, because when you transpose it, it then becomes a 2 by 3, as you might imagine. 2, 7, 9, 6, 8, 0. Do you see how that happens? So now it's a 2 by 3. So it does have that property of flipping these, which you just don't notice in a square matrix. Let me see, is there anything else about transposing? I think that's pretty much it. There are some properties, which I will go over quickly here. And I'm just going to type them out, because that makes it a little easier. Well, let's see here. I already showed you one of them. If you transpose it back, you get the same thing. So I'll just go over these real quick. So the first property, which we already sort of touched on, is A transposed again, A being a matrix, equals the same thing. Another property is if you scale a matrix, let's say this little lambda symbol here is some scalar number. It could be a 5, a 10, or whatever we want to scale by in A's matrix. So if we're scaling it and then we transpose, that is the same as scaling it after a transpose too. So it doesn't matter what order you do the scalar in or the transpose in, it equals the same thing. And there's also this property where if you have two matrices plus each other and then you transpose the result, you could also transpose each of them first and you get the same thing. And a few more here. Well, this scales out as far as you want. You could add in a C here, and like if you put a plus C here, this would also be there too. So that goes as far as you want. And multiplication is sort of the same with that rule. So if you have A times B matrices transposed, it is the same as A transposed times B transposed. And yeah, this one scales out further as well. Like if you have a C in here, it would also have a C here. And that pretty much covers transposing. Just remember to flip those columns into rows, and that's pretty much it. Thanks for watching. Hope this helps with your matrix math and your transposing, and I'll see you in the next episode. Have a good day.